So let's see the next problem. So this is from now IITJEE 2020, JEE Advanced 2020. This is also in paper 1. And it says that, so suppose S is the set of complex numbers which satisfies that mod of z square plus z plus 1 is 1. Then which of the following are true? And we are given some inequalities. So again, whenever you see that, okay, you are given that this is of unit magnitude, then it makes sense to assume that, okay, so let z square plus z plus 1. So let this be equal to e to the power iota theta, right? And I can assume that theta lies between, say, minus pi and plus pi. And now this is now a quadratic equation. I can actually solve for z. So I'll get minus 1 plus minus square root of, okay, so I can take this to the other side. So I have b square minus 4a times c over 2a, right? So this is like minus half plus minus square root of minus 3 plus 4 e to the power iota theta by 2. So the set of these complex numbers are of this form. Okay. So firstly, we see that what is mod of z plus half. What can we say about mod of z plus half? So z plus half is going to be plus minus square root of minus 3 plus 4 e to the power iota theta by 2, or mod of this thing is going to be mod of this thing, which is going to be half of mod of square root of minus 3 plus 4 iota theta, right? And we know that the mod of root z is going to be square root of mod z. So here we can actually take mod inside the square root. And if we look at now this quantity, this expression minus 3 plus 4 e to the power iota theta, the magnitude of this thing, we can check that this magnitude actually lies between, okay, so minus 3 plus 4 e to the power iota theta. So if I apply, say, okay, so basically this lies between, so here if I have a point, say minus 3, and I draw a circle of radius 4, right? Yeah. So essentially it will go something like this. And now the least magnitude point, right, and the most highest magnitude point I need to find out. So the highest magnitude will actually occur when minus 3 and 4 e to the power iota theta, they are like parallel to each other. And the least magnitude will occur when they are anti-parallel to each other, right? So the magnitude of this will be at max 7, right? This is when they are in the same direction, and it can, at min, it can go to plus 1, right? Because this is when they are pointing in opposite direction. Or even in general, you can apply the inequality that mod of z1 plus z2 is less than equal to mod z1 plus mod z2, right? So the mod of minus 3 plus 4 iota theta is less than equal to 3 plus 4, which is 7. And also we have a similar inequality that mod of z1 minus z2 is greater than equal to mod z1 minus mod z2 mods. So these are two forms of triangular inequalities. If I apply this one, I'll get that. So let us say that I put z1 equals 4 to the power iota theta, z2 equals 3, then basically I'm going to get this is greater than mod of 4 minus 3, which is 1. So basically we see that this expression lies between 1 and 7. So what we had now is that mod of z plus half, this lies between, so this lies between where to where? So it lies between square root of 7 by 2, and it lies between half. So it lies between half and square root of 7 by 2. So it's definitely not less than equal to half, it's only greater than equal to half, right? And for all z in S, yes, this is true. And what can I say about now mod z? Okay, so now if I look at mod z, where should it lie? So I know that mod z plus half, actually it lies on this sort of circle, right? And so where can now z lie? So for that I can say that mod of z equals now mod of z plus half minus a half, right? So which is less than equal to mod of z plus half plus half. And mod z plus half, I just find out that it is less than equal to root 7 by 2. So overall this is less than equal to root 7 by 2 plus half. And we know that root 7 is less than equal to root 9, which is 3. So this is less than equal to 3 by 2 plus half, which is 2. So mod z is less than equal to 2. So hence this is also 2. Now it says that the set S has exactly 4 elements, right? But as we see, we have computed an expression for this z, and for every theta I'm going to get a new value. So definitely it has like infinite number of elements. This set S, which satisfies this equation, has infinite number of elements, right? For every theta I'm going to get a new element. And so this just definitely has more than 4 elements. So this D is wrong and this A is also wrong. So here we have B and C. So this is a multi-correct question. We have 2 correct answers, B and C. Yeah, so convince yourself, do those arguments yourself, and you will be able to figure out the 2 correct options.